I want you to do something for me. Close your eyes for a second and picture the most extreme flooding you've ever seen in a news broadcast. Maybe it's a river overflowing its banks, swallowing up cars and houses. Now multiply that. Keep multiplying. And then multiply it some more until every single mountain range, every continent, every last bit of land you have ever stood on is completely and utterly submerged beneath a global ocean. No beaches, no coastlines, no dry land anywhere on Earth, just water in every direction all the way to the horizon forever. That is not a fever dream. That is not science fiction. That is a hypothesis that a growing number of geologists and planetary scientists are taking seriously about our own planet roughly 3.3 billion years ago during what's known as the Archean Eon. And the story of how Earth may have briefly transformed into a genuine waterworld is one of the most mind-bending chapters in the entire history of this planet. Now, to understand how something this extreme could even be possible, you first need to understand what Earth looked like back then. Because here's the thing people forget. The Earth, you know, with its giant sprawling continents, its mountain ranges jutting miles into the sky, its deep trenches and ocean floors, that version of Earth is relatively new. In its early days, our planet was a very different beast. Hot, volatile, geologically hyperactive, and critically, still in the process of building its continents. And it's that last part that is the key to everything. You see, the continents that we all live on are not permanent fixtures. They're enormous slabs of relatively light rock called continental crust, and they've been growing very, very slowly over billions of years through a process tied to plate tectonics and volcanic activity. But roughly 3.2 to 3.3 billion years ago, the evidence suggests that this process had simply not yet produced enough continental crust to keep land above water. And so the question becomes, how deep exactly was the ocean back then? Well, this is where things get truly astonishing. Because research published in the last decade, including a landmark 2021 study analyzing ancient ocean floor rocks from the Dresser Formation in Australia, suggests the early Archean Ocean wasn't just bigger than today's, it was substantially deeper, covering potentially 97 to 99% of the entire planetary surface. And here's why. Today, roughly 71% of Earth's surface is ocean. But the ocean water itself has nowhere to pool except in the relatively shallow basins carved out between the continents. Remove most of those continents, the same volume of water now spreads across the entire globe, and suddenly you have a planet that looks, from space, like a giant blue marble, a true water world. But before you start feeling a bit sorry for whatever was living down there, let's talk about what life actually looked like in this ancient ocean. Because here is the beautiful irony of this whole situation. Despite the apparent hostility of a world completely covered in water, life was not just surviving, it was thriving. The earliest confirmed microbial mats and stromatolites, those layered structures built by communities of photosynthetic bacteria, date back to around this very period. And the ocean itself, though alien in almost every other respect, was essentially their entire universe. A warm, mineral-rich global soup teeming with the earliest living things on the planet. So in a strange way, the waterworld Earth wasn't a dead planet. It was arguably one of the most biologically productive environments in Earth's entire history, relative to the complexity of life that existed at the time. Now, the ocean back then wasn't exactly what you'd want to go for a swim in, to be very, very clear. For starters, it was significantly warmer, with estimates suggesting surface temperatures anywhere between 40 and 85 degrees Celsius in some regions, which is, for reference, not far off from a hot tub on the mild end and closer to a pot of soup on the extreme end. And it was also chemically brutal. The early ocean was rich in dissolved iron and largely devoid of the free oxygen we now take for granted, giving it this strange greenish, rust-tinged appearance. And the sky above it wasn't a comforting blue either. With minimal oxygen in the atmosphere, it was more likely an eerie orange-pink haze, lit by a sun that was paradoxically about 20 to 30% dimmer than it is today. So your waterworld also came with a weaker sun and a toxic sky. Not exactly a holiday destination. So what ended it? How did Earth go from being a planet entirely swallowed by ocean to the land-rich world we live on today? And the answer is, very slowly, and through one of the most powerful geological forces our planet possesses. Plate tectonics. Over hundreds of millions of years, the process of subduction, where oceanic crust gets dragged beneath other plates and melts back into the mantle, started producing the granitic, lighter rock that forms continental crust. And as more and more of this lighter rock was generated and pushed upward through volcanic arcs, land began to poke above the waterline. Slowly at first, then more and more. And as land emerged, it also started pulling water out of the ocean through weathering processes, locking water molecules into new minerals. So not only did the land grow, but in a sense, the ocean itself shrank. The transition wasn't dramatic or sudden. There was no single moment where the seas parted and the continents rose like something out of a biblical epic. It was a grindingly slow geological waltz that played out across hundreds of millions of years, with the continents gradually winning their long war against the ocean. By about 2.5 billion years ago, enough land had accumulated that the Waterworld hypothesis no longer applies, and Earth's surface had begun to resemble something, at least vaguely, more like what we'd recognize today. And in some ways, the disappearance of the Waterworld Earth is just as fascinating as its existence. Because the emergence of those first continents fundamentally changed everything. It changed the chemistry of the ocean. It changed the climate. It created new ecological niches that life would eventually crawl into, walk across, and one day build cities on. Without the end of the Waterworld, there is no land. Without land, there is no terrestrial life. Without terrestrial life, there is ultimately no us. So the next time you stand on a beach and look out at the ocean and think that it's big, just remember that there was a time when you would not have been standing anywhere at all. There would have been no beach, no shore, just water, all the way out and all the way back, covering every inch of the world you call home. And somehow, impossibly, out of that ancient drowned planet, everything you have ever known eventually rose. Anyway, thanks for watching.